Good afternoon. Thank you for coming to the talk. And yeah, it's the 33rd edition of DEFCON, and it's better than ever. So the talk, as you can see, is based on the title of the talk, as you can read, right? No radios, no problem. Okay. The title of the talk, as you can see, is No Radios, No Problem, Hacking Wi-Fi in the Virtual World. So what we are going to do in this is, we are going to talk about the first principles, the basics that you can use to emulate Wi-Fi in a VM, in a cloud, anywhere. And we will also discuss why it is important, what are the other easy ways of doing it. But the idea is there are so many tools out there that you can use, but they don't really give you the full understanding of the basics that you are using. And some of these basics are also related to containers, Docker containers, Podman, all the other things, right? So we'll talk about them, and looking forward to this. A little bit of introduction. My name is Nishant. Been doing Wi-Fi for 10 years now. Was in cybersecurity education for almost all of my career. Currently serving as the head of research at SquareX. This is my second time at RF Village. I have also taught Wi-Fi hacking classes at Black Hat for 2 to 3 years. So yeah, that's all. So first question is why exactly we want to do this? The simple answer is you can buy one device, you can buy it for 2.4 gigahertz, you can buy it for 5 gigahertz. But then when things get more complicated, there is a limit how many devices you will be able to buy, how many devices you will be able to set up, how many devices you will be able to play with, right? And if you want to simulate complicated scenarios, so for example, you want to simulate 100 devices, 10 access points, they are connecting, disconnecting, they are moving farther, backward, right? And then you also want to do Wi-Fi security on it. When we talk about it, Wi-Fi security is your monitoring. After that, you analyze it, and then you also attack the older schemes. We know that WPA3 is practically unhackable, if you want to put it that way, right? If you're not talking about social engineering and all the other kind of deceiving attacks, if you're talking about technical attacks, WPA3, they have kind of locked everything down. However, if you talk about WPA for some reason, WPA to enterprise, you have your MS CHAP, V2 and all of that, right? So that still you can hack, and a lot of places that is what you're going to find as well till today, right? Even today. So if you want to practice that, this setups give you more flexibility. And the reason we had built this is because at one point of time, we were building Wi-Fi labs in the cloud. We did that, all of that worked great. So same things we are going to discuss. It's scalable, it is easy to set up. You can set up it in the cloud, in the VM. If you make a mistake, you just take it down, run it again, good as new, right? And for the new people who are trying to learn Wi-Fi security, it is very, very, very helpful, because you don't have to deal with all the uncertainty that comes with real packet captures, right? You're not able to find the packet, and I'll say 50 to 60% of the mistakes that are there are when you're capturing it. So again, this doesn't really mean that you can get away with that part. If you're doing it in real world, obviously you will have to learn how to catch the packet correctly. And that's a combination of your tools, bands, and the hardware. If it is an 11 AC that you are trying to sniff, you have to make sure that your device is also 11 AC, and you are also supporting the bands and the MIMO and all the other things, right? You have the throughput requirements of the same and all of that. So 60 to 70% work is there, and it is still need to be done. However, if you just want to skip that part, you're like, okay, I get it, it is complicated, I can do it. But right now, I just want to talk how to analyze it, how to create my own scenarios, how to attack these things in a VM. That's what we are going to talk about. So this is pretty much what you need in terms of basic principles. This will create your first setup, and then on this setup, just like you use your Kali attacker tools, you use your air mons, air dumps, and then all the other WPS, Wi-Fi, all of that can run on top of this, because all of these tools, they assume that you have a Linux machine, you have a Wi-Fi adapter, which is in monitor mode, and then you are doing things on the basis of that. So we are talking about this lower stack, how to emulate it, because once you have it, it's on a Linux machine, you can pretty much install anything and everything that is there on a Kali box. So what all is this? First thing, obviously, Linux required. The main secret of this recipe, again, it's not really a secret. This thing is there for multiple years now. So I'm talking about 802.11_SWSIM. This is the hardware simulation for the Wi-Fi module. It is there in the Linux kernel. Means it doesn't come as a package, but you can pretty much use 2 to 3 commands and get it on your machine. It is there for multiple years now, but most people don't know about it. Most people are using it when they are using some other tools, and we'll talk about them as well. But behind the scenes on Linux machine, if you are emulating Wi-Fi, this is what is going to be used, because this thing gives you the exact packet capture as you'll get in the real world. If you do a raw packet capture on it, if you do a monitor mode capture on it, it is the same beacon frame, it is the same probe request, it is the same probe response that you're going to see in the real world. So that's there. Then comes namespaces. So Linux namespaces is a concept that we'll talk about. Why it is needed in our setup, we'll talk about that. After that, hosted PD. I'm very sure most of you are already aware of it. It is the most used, I'll say, access point creator. That's the easy term for it. If you have a Linux machine, if you have an IoT device which is running Linux, like most of your, your access point devices, your OpenWrt and all of that. On that, if you want to create an SSID, that's the Wi-Fi network, wireless network, this is what you use. It is battle tested. It is around for more than 15 years. Most of your enterprise grade, machines, APs, they actually use this thing. And you can pretty much use it in like 2 commands. We'll use that to create our access point. Then WPA supplicant is the another part. It comes installed in your Linux. This is the thing that makes your Wi-Fi card to connect to your SSID if it is protected. So when you are connecting to a WEP, WPA2PSK, WPA, EAP, this is the thing which is making that handshake, and you can see all of that in the logs as well. So we will be using this to create or emulate the client. So we'll do this for one thing, and the same logic with some shell scripting, Python, you can actually then replicate it, you can create a big scenario. So in one PC, one virtual machine, you can have like hundreds of these devices connecting to each other, roaming. And if somebody just takes a look at the packet capture, barring the signal strength, that's the part that another tool will take care of. It will look like it's a high-density Wi-Fi environment. You are seeing all of this traffic. It behaves just like Wi-Fi. It will have channels, and you will have to hop the channels to here to all of this. So till here, you are covering layer 2. So your layer 1 is obviously physical. Second is the MAC layer. That's where your Wi-Fi actually operates. Then comes the IP layer connectivity. Because if you really want to emulate it, this part is simple. The main complexity comes after this, because you have one machine. On that one machine, obviously, if you can create 2 of these interfaces, and you can make one of them as access point, another one is a client, you connect them up. After that, you need to give them IP addresses if you really want to simulate traffic. And that is where the namespaces and all other things will come. So yeah, DNS mask is going to be our DHCP server, and then DH client is going to be the client which you will use to request for an IP. And once you have layer 3 connectivity, after that, you can pretty much run any server, any appliance, and simulate all the traffic that you want to do. Once layer 3 connectivity is there, after that, the only thing that remains is to install stuff and then use it using some scripting. So this is the whole stack. That is how it looks like. So what do you need? You need a Ubuntu desktop. I have used 24.04 just to keep it fresh. Once you have this machine, and you can, either install it from Ubuntu's website, you can take an ISO or VM from there. Or if you want to save some time, you can go to osboxes.org. It's a free site. I'm very sure most of you have used it. You can directly download a ready-to-use VM from it, and you download it, it is ready to use. And obviously, when you will run it, I'll obviously not go through the setting up part. I'm very sure that most of you already know it. VirtualBox you can use, VMware player you can use for it. You're running it on a Linux machine, Windows machine, doesn't really matter. It's a guest VM. Once it is up, if you go inside, you'll see that obviously there is no Wi-Fi. because again, you have not plugged any adapter to it, we have not started our work yet. So once you're here, after that, we are going to use this MAC 802.11 hardware simulation. So what it allows you to do is, it will allow you to create these fake radio adapters on which then you can make them act like any way you want. So there is no limitation. It will replicate what your real device does. It will behave in the same way. So these are the commands. First command obviously is to check the kernel version, and second command is to install the build essential, because that will be required. As I mentioned, it does not come with the default kernel. You have to download some extra Linux modules, and then you have to inject this to create these fake Wi-Fi adapters. And that is what we are doing here. If you take a look at the third line, so in the second line we are installing build essentials. We are also downloading and installing Linux modules, the extra ones. It's a package, you download it, a lot of other things come in. Once it is done, you have to use the third command, that is modprobe. So modprobe is a generic command, it's not specific to this. You use it to inject kernel modules on runtime. So that is what we are doing here. So when I say kernel modules, these are the packages which are going to enhance or increase your functionality of your kernel, right? And the reason it is not shipped with the default kernel is because you don't really want to make it bulky. There are like hundreds of these things which are specific to some purpose. You don't want to make it heavy, but at the same time, you want the people who really want to use them to have an option to use it, and that's what it is. So you can use modprobe, you can give the name of the module, and then, as you can see, there is an argument, radio is equal to 3. It means we are asking it to create 3 virtual radios, and that is what it will do. So once you do this on the Ubuntu machine, you are going to see 3 of these interfaces, WLAN 0, WLAN 1, and WLAN 2. And you can verify that using this ip-link show command. This is how it will look. So it is that easy till this point to actually get 3 virtual Wi-Fi interfaces. These interfaces are going to behave just like your real adapters behave, minus all the limitations. You don't have to worry about if it is a 2.4 gigahertz, 5 gigahertz, does it support 80 megahertz or 160 megahertz or not, right? You don't have to worry about it. They support everything. And they'll capture all the traffic perfectly, because again, it's software layer. There is nothing, there is no unknown in this. And that's why this makes a very, very, very good bed for lab and practicing. And the same is also being used by people to simulate, high density environments, to run simulations there. So here, the thing that we have highlighted, SWSIM0 is the device that will tell you that yes, it is working. Then WLAN 2, WLAN 1, WLAN 3 are the virtual ones. And there is no limit. You can actually put 16, 17, 20, 25, and you will see all of these devices here. So once this part is done, if you do IWDev, just like you do when you connect any kind of adapter to your Linux machine, you see all of these, right? Same thing. And now if you go back to your UI, suddenly there are 3 Wi-Fi adapters with you, which you can use to connect or to do something else. This UI part obviously is just to show you that it is system-wide. It's not happening just on the command line, but it will happen here. If you try to interact with it, it will work just like a real device. And even if you take a capture, you'll see the exact same thing that you see on the real devices, apart from the fact that it is not from the outer world, it is from the inner world. So now what you want to do, and what we are doing here for this example, so you are seeing 3 of these. Now what we will do, we will take one of this and we'll make it play as client, and that's where the complexity starts. So till here, only 3 commands, not much difficult. So what we are doing here, whenever you are plugging anything to your desktop Ubuntu, it has a network manager running in the backend. And that will create a lot of problems when you are doing these things. If you know what you are doing, just turn it off. If you are not using that VM for anything else, just turn it off. It is going to do a lot of other things otherwise. But here, what I'm doing is, I'm just removing one of these devices, WLAN 2, from the managed mode, so that this network manager is not messing it up, because I want to move it to an isolation where I can make it use or work like a client. And we'll do all of that in the same machine. That's the beauty of it. And you can do it multiple times. You can have 15, 20, 100 of these on the same VM. And good thing is they don't even need very powerful machine. You can actually take a bare minimum VM spec and it will run on that. So once that part is done, if you go here, what I'm doing here is pretty familiar to, I think, most of the people. So this is a bare minimum open network configuration for HostAPD. HostAPD, as you remember, I just described, it is the software that all of your enterprise devices, all of your Wi-Fi devices which are running on Linux, use to create your Wi-Fi networks. The SSIDs are created using this. The configuration are also like this. The only difference is when you do it in real world on real devices, you'll see much more parameters here. So HostAPD in total actually supports over 150 plus parameters. Good thing is, even if you don't define them, it will assume default values. And it will only take the values that you are providing and make them different. So you have provided that part. And then here you are just running it with the configuration file. HostAPD is very easy to install. You can do apt get install HostAPD. It just works. And the reason I'm not going into each and every command is now because you have ChatGPT 5. So yeah, way easy. See, I feel that the way today's world is working, if you know what you're looking for, it is very, very, very easy to start from there. However, a lot of people don't really understand the basics of it, and that's what I'm trying to clear up. Rest, using ChatGPT and Claude and all of that, you can write very powerful simulations around these basics, which will create the main setup. So once you do this, you have an access point running. You have an SSID. The name is OpenTestNet. It's on channel 6. You can assign it a MAC because by default, when you inject these, the MAC is 0000.2 or something, right? Which looks very odd when you capture traffic on it. But yeah, once you have this, you have SSID running. And if you go back to your GUI, you'll actually see that there is a network operating here. Just like you see in the real world on your machine, right? Because again, exact same thing. And if you click on it, on the HostAPD side, you'll actually see all of these log appearing. So what we just did, we made layer 2 connectivity between these two interfaces on the same machine. Again, it is a layer 2 connectivity. You don't really are dealing with net masks and layer 3 complications as of now. So that's why we can keep them in the same space and nothing will, break loose. However, when you want to move forward and you really want a real lab, a real connected lab where you are, maybe running a web server or something on one side and client is then trying to access it, or you have a P2P application that is running on different clients exchanging the traffic through the access point, you will need layer 3 connectivity. And that is where the concept of Linux namespaces will come in. So I'm very sure that most of you guys have already worked with Docker containers. So your Docker containers, or for that matter, any kind of Linux containers, they are built using Linux namespaces. What are namespaces? This is a way to isolate the system resources. So if you want that on the same machine, when I list my interfaces, I should be able to see two resources on one side and another one in another section. And these resources should not know that there are other resources on the same machine. So you are isolating them, same way your containers do. So when you are running a process in a container, it does not know what is happening outside of container, what is happening in the another container, and that is also implemented using namespaces. So for the containers, you use process namespaces and network namespaces and IPC namespaces and mount namespaces. However, in this case, because we are just concerned with the network part of it, we can just use network namespaces. So this is how you set a network namespace. You do IP netns, again stands for network namespaces. Then you say add, and then there is the name of the namespace. It can be anything. It's a construct that you are creating so that you can isolate these on the same machine. Because if you don't isolate it, then there is a problem called ARP confusion or something. So there is this thing, if you have two interfaces on your machine, if they are able to see each other, and if they have IPs from the same subnet, the machine doesn't know which interface is the right one. So it tries to send the traffic from both of these interfaces, and what will happen? Your machine will actually lose connectivity. It won't be able to work because your packets, they're going from one interface and then they're trying to come from another interface. So to avoid that confusion, that's where your network namespaces are required. So what we are doing here is we are setting up one more namespace. So when you log into your machine, there is always a default namespace. That is where you are playing most of the time. You only go into creating additional ones when you want to do something like containers. Containers do this all the time. That's how you can see a ETH0 inside the container and outside as well. So same thing we did here. We created a namespace. After that, we made sure that that namespace has a local interface. It is the local host, local interface that you see. And if you want to check the namespaces that are created, if you do list, you'll see the one that you have created here. Once that is there, what you can do, you can take one of these devices and you can move it over into the new namespace. So this command here precisely does that. When you say IW, this is the utility that you use to play around with the Wi-Fi components. PHY stands for physical device. PHY2 stands for physical device 2. So if you go back and if you take a look at this here, what you will see is that every device, every virtual device, just like the real device that you plug in, is marked with the name. In this case, it is PHY2 that we want to move. So you go back here, and that is what you have done. Now, after doing this, if you run IWDev, surprisingly, or not surprisingly, because we knew this is going to happen, PHY2 is not there anymore. It has moved. And currently the command that you're running, it is running in the default namespace. So that's why you are not able to see it. Your commands are not going to see it. And that is precisely what we want if we really want to do layer 3 connectivity on the same machine using the same subnet. And this can be extended, and that's how your containers also work. They are on the same machine, they have different interfaces, you are doing networking between them, they are in the same subnet. Still, everything runs. Why? Because these interfaces are not seeing each other. They feel that they are in separate machines, and that's what we are doing here. So you have physical 1 and physical 2 in this namespace. If you go to another namespace, so here, when you run IP link like this, it runs in the default namespace. You are seeing 2 of these devices here, and then you use IPNetNS. So this is the command that you use when you want to run a specific command in a specific network namespace. So you do excc, that is execute, name of the network namespace, and then the command that you want to run. So now when we are running it, it is not in default namespace. It is in the namespace that you created, and as you can see, it also has a local one, and then WLAN 2. So now WLAN 2 cannot see WLAN 1 and WLAN 0. And that's the magic behind your virtualization of this kind of lab. It is the same concept that we have borrowed from the containers. This is how containers are working behind the scenes, and you can extend the same logic for this. There is also one more module on similar lines. It's MAC 8015. So you can also use that to simulate that network. As far as my knowledge goes, currently there are only 2 of these modules that you can use to simulate it very closely. There are multiple other options as well, but most of these options, they actually emulate, they don't simulate. So if you take a packet capture and if you take a look closer on their behavior, you will actually see that their behavior is very different how real devices work. But in this case, it is as good as your physical device, apart from the fluctuations in the power and the physical disturbances. So once our setup is ready, what we need to do now? We are taking this one interface, WLAN 1, on which we have already created an SSID, because we are now talking about layer 3 connectivity. We need IPs. So we are setting an IP address on it. Then we are turning it on. If it is not on, it's already on, but just to be sure. And then we are creating this. This is the same file that we have used to run that access point. You can also run it in as a daemon. by using -b. So that's what we did. Access point is enabled. And this is the default namespace that we are currently dealing with. SSID will start. If you do iwdev, you'll see that instead of saying managed, now it will say access point. Because it is operating an SSID, right? HostAPD is making it do this. The second one we are not playing with. This is the one that Network Manager is currently playing with, the Ubuntu Desktop Network Manager. You can safely ignore it for now. Then comes the client part. And this is where you actually run this logic in the other namespace that you have created. So you first switch into the namespace. So what I'm doing here, I'm launching a bash shell in this new namespace that I have created. Once you do that, you are inside it. If you do iwdev, if you run any other commands now, because you're inside the bash which is running in this namespace, it won't show you the interfaces that are there in the default namespace, but only the one that you moved and the local one. And after that, we created this very simple configuration file. It is to connect to this open network that is there, and then we will use WPS supplicant. We'll give it the interface name, and then we'll give it the configuration file. So whenever you're using a Linux machine and you're connecting to any network, back in the back, WPS supplicant is the one that is running and doing all the job. So here we are just running it using the command. Otherwise, when your network manager has to connect it, it also is going to call it. So by doing this, now you have that connectivity. And after that, the only thing that remains is on the access point side, you have to run DNS mask or any other tool which can run a DHCP server. That part is done. Then you come on this side and you run DH client, which will request for the IP address, and it will get the IP address, and you have full layer 3 connectivity on the same machine. So this is the basic construct. Now, once you have this, as you saw, everything was done using Linux commands. How do we automate it? You write a shell script which will generate random names, random IDs, and then you loop over it again and again and again, depending on what exactly you want to make. If you want to simulate 5 to 6 of these networks, you can make a more elaborated or multiple host APD configuration file. You can run it and you will have 10 or 20 or 30 or 40 networks there. You want to create roaming clients, just create clients, run WPA supplicant on it. They'll start probing. If they find the network, they'll connect. If they connect, then if you're running DHCP, they're automatically going to get IP connectivity. So this way, you can pretty much simulate, even WPA3 you can simulate. That's another thing that you won't be able to break it. But if you really want to quickly capture packets of the handshake, for WPA2, WPA3 as well, there is a handshake. Even if you want to simulate WEP for some reason, right? You are trying to look at packets, you want to see how exactly those attacks used to work. It will work perfectly in this case. Why? Because you're not missing any packet. You'll see everything, and again, this also has a channel of concepts. So you still have to use your arrow dump to jump around, to see all the things, and then to set on one channel, then to lock on one target, and then to do all of this. So yeah, this is how you do it. It will run on your any kind of VM that you run. It actually even runs on OpenWrt. So if you for some reason you want to do that, you can do that. It also runs on Raspberry Pi. We tried it there as well. So yeah. The only thing is that when you do this on IoT devices, sometimes you might have to compile their kernel and their firmware using the build chains. In desktop it is easy, that's why I'm showing this to you. If you try to do this with OpenWrt, you have to take the whole source code, you have to make the changes in the configuration file. So when the kernel is compiled, at that time you can do this. So it is a little bit more difficult, but not impossible, you can do it. So if next thing is, what if I'm too lazy to do all of this? Okay, I understand there are namespaces, okay, I understand there's HostAPD and WPS supplicant and all of this, right? But I don't really want to, get into scripting and to fix it, even with Claude or, your other things. So in that case, people have created something like this. They have Mininet Wi-Fi. How does this work? Exactly the way I stated. So what they have done, they have taken the same construct. They have done all the plumbing for you. So you can just run commands, and by using these commands, you can pretty much simulate all the things that we just discussed. You can have multiple clients, multiple APs, all of that by using very simple things. And here you are seeing a diagram that I have taken from their site. And the reason for that is just to show you that all of this you already know now. So you have these WLAN 1, 2, 3, same thing, how they're doing it, same module we talked about. Now we know how to inject it, how to do it on our own. This is called netlink socket. Means it is not really, it is here for depiction purpose. This is how it actually works. But yeah, you don't need to know about it. It automatically just works if you are on Linux. And here they are creating different namespaces. And in the namespaces, they are mapping these same way like we did. And on top of that, then you will have your connections and all. So easy way, very good documentation as well. Till the time you are not trying to simulate something very complicated, it will just work. And then what is more that these guys are providing that we didn't discuss? So we didn't discuss the physical part of Wi-Fi, because as your access points are at one place, your clients, if they are moving, the signal strength is going to be varying, right? Even if the access point is stationary and you are also stationary, due to the physical factors, there are so many things that actually interact with Wi-Fi signals. So even if I stand here, the Wi-Fi is stationary right there, you'll still get packets of varying signal. So all of that, if you want to simulate, then this thing can do that. It simulates moving targets, so you can actually code or tell it to create moving clients from one access point to another access point, and you'll also see the switching being happening. So when you are moving in a very big campus, you see a lot of these access points deployed, and what happens is when you move from one location to another, automatically a handover happens. So you switch from one access point to another one, the same way you switch your mobile networks when you move through space. This thing can also simulate that part. So you'll see one client disconnecting and connecting on the other side, and that's the reason why you can use this to run simulations on a bigger scale. Propagation also, but that's not really for security purpose. That is if you really want to understand how the propagation works in Wi-Fi. So that's also there. And good thing is that now they also have an easy to deploy container mode. So you can just run these commands. It will create multiple containers. These containers, if you go into these will behave like different machines which are connected using Wi-Fi. So it was very easy to do in Docker. Now you can also do it using Wi-Fi, where it feels like that you are using a wireless network, but essentially it is nothing but software. So yeah, very easy to use. What are other options? So you have NS3. It's called Network Simulator 3. It's more for the wired thing or the protocol part, but can we do 802.11 on it? Yes, you can. However, if you try to capture the packets, the captures won't work the same way as they will with 802.11 SWSIM. You have another thing called core. You can look it up. That's another solution. It is more tightly coupled, so you cannot change a lot of things there. That's why not really the best place to start. Then you have Mininet Wi-Fi, and then obviously GNS3, but GNS3 does not really support the Wi-Fi frames. So you'll only see these being emulated. You'll see the traffic of layer 3 and above, but layer 2 you won't be able to see. So these are the different ways by which you can you create your own cloud Wi-Fi lab or your home Wi-Fi lab, where you can have multiple of these devices, and then you can run simulations, attacks, floods, DOTs if you wanted to do that, and now WPA3 is not letting you do that. You can create one and then do a DOT there. You can study the behavior. You can see in Mininet. In Mininet, you can actually see that when you move a client and if you DOT it, it will go for the nearest one with stronger signal. So all of these things you can literally see, which are very difficult when it comes to simulate these in real world. In real world, you can speculate and then you can observe. Still, you are going to be wrong for the most part. So yeah. So that's all. If there are any questions, please throw them my way. Thank you.